Welcome, I'm Taylor Sharpe, and this is the August 2024 FileMaker Pro User Group. I'm Chapter Co-Coordinator along with Fred Craven and Greg Price, so we're glad to have everybody here today for another exciting learning and diving deep into FileMaker. On the announcement end of the world, I assume everybody knows over this last month we now have FileMaker 2024, and we'll be talking more about that, so if you haven't upgraded, time to upgrade. Other announcements, I'm going to pause on air. I know a few others are going to that. I did hear from Paul that there won't be a Berlin conference, but there is going to be a Vienna conference next year if you're able to get over to Europe. So who knows? We'll have to see what FileMaker does as far as a developers conference. They still haven't announced anything yet, so I don't know if we're going to have like an Austin Engage again or not next year, but we will see what happens. So that's all up in the air. For future announcements, next month we're going to talk about Let's Encrypt and find out how to work some weird exceptions, like hopefully it'll be working in Windows then, and also if you follow the instructions now, you will not be able to get it to work on an Intel Mac. So silly, those of you who've tried some of those things, you'll find those out. Other announcements, October, we're going to have an accounting presentation, and so we're looking for people who, accounting is kind of one of the bread and butters. If you're in the FileMaker development business, you've obviously ended up having to do some type of accounting modules. So we want to talk about and bring different aspects to that as a general discussion in, and so we're looking for who all would like to be a part of the presenting about accounting packages in October. So get back with one of us that are of the chapter co-coordinators, and we can see if we can get together on that, and it should be fun and exciting. After that, we are open, so we're probably looking for some presenters for later in the year. So if you happen to have some burning thing you want to present for us, certainly let us know about that.
All right. Welcome, everyone. It's great to have you here in person and on the remote call. Happy to have you join us. My name is Steve Sykora. I'm one of the owners of Harmonic Data and one of the sponsors of the Dallas area FileMaker Pro Users Group. We've got some new tech going on today. As you've seen, Fred and Chris have been working on making things work even more smoothly and cleanly as far as video, audio, recording, streaming, etc. So we're trying to sing and dance and chew gum and so forth all at once. We've been really happy with how it works in testing. We hope that the experience is good for you. Looking forward to your feedback there. So thanks, guys, for that work on that. August of 2024 is a special month for us here at Harmonic. We are 20 years old. This is our 20th anniversary year, starting August of 2024. Thank you. Yeah, 2 decades ago, Matthew Monroe, in the back of the room, Matthew Monroe and I incorporated Harmonic Data Associates, Inc. in the great state of Texas, and been going strong ever since. It's been my honor to work alongside many trusted colleagues for our wonderful customers, solving problems with them. We're very excited about what the future has in store as we go forward. In celebration of that, today we're inviting everyone here who's able to join us in person. We're going to have lunch upstairs. We're doing taco bar, but we also have a happy anniversary cake. You see a picture overlaid on the screen here, baked by our in-house baker, Heather McHugh. Yeah. There we go. That's right. So happy anniversary, Harmonic, yeah. So as most of you know, as Taylor reminded us, Claris has recently released FileMaker 2024. A lot of exciting stuff there. Last month, we talked about the new features that weren't FI that we were interested in, had 3 new features. If you missed that, feel free to look back at our video catalog and review those. Some of those were quite interesting. This month, we're going to talk about AI, right? Because that's really the big thing, right? That's the headlining feature of FileMaker 2024. Talking about AI right now, though, it can kind of feel like shouting into a hurricane. There's certainly a lot of noise, but we're not sure where everything's going to land, right? So today, we have 3 presenters to help us make sense of that, right? And the real angle here is, what are we actually doing right now ourselves with our businesses, with our work, with our research and development? What are we doing right now with AI and FileMaker 2024? With that addition of Semantic Search, Chat with Database, they've opened up a world of possibilities for us. And I'm excited about the future. Mike Wallace is going to be our first presenter, Jeremy Bante. And then for my team, Eric Clark and Randy Crowley. They're going to show us what they've been working on. We hope that you're inspired with what we have to show you, right? And that it helps you think about how you might start engaging with AI and FileMaker. We have a great community of FileMaker and Claris experts in the room and in the community. And any of us would be happy to chat with you about the possibilities. Let us know how we can help. With that, Mike, you're up first. Thanks so much.
All right. Well, first of all, I want to touch on the fact, what is semantic search? Because I see a lot of people butting their heads against things, trying to do things that is not what semantic search is. For example, I hear people complaining, well, semantic search doesn't find well when I'm looking for this number and matching with this other, that kind of thing. Well, 5 doesn't mean 5. 5 is 5. Whereas if you want to, do a search for something, it's a good idea to organize your data in a way. For example, customers really like this. Customers kind of like this. Customers don't like this. Those wordings like that will find a lot better with semantic search than just a rating number. And especially if all you have is just a number and there's no meaning associated with it. I've shown this a couple times with semantic search and that kind of thing on the Claris Live and on other videos I've done and such. In fact, I touched on this one on the Claris Live. This is an expansion of doing semantic search, where I have actually run, so on each of these different books here, I supplied a rating from 1 to 10. And then I did a semantic search, not by searching up here for like a text block, which I can do that. I can say, Star Wars, for example, and it will bring up all the books that are like the phrase Star Wars, which is interesting because it's not Star and it's not Wars, it's Star Wars. So like Star Wars has a different semantic meaning than Star, than Wars. In other words, the AI, that's where the magic comes in, is because the AI assigns a meaning or a number or many numbers to that meaning. Actually, it will be more likely to find Star Trek than it will be to find something else. So, because science fiction and that type of thing. But yeah, so it actually is, if you think about like all the different ways that you can describe Star Wars, all of those different numbers are all generated to equal that. And you might find, for example, Luke Skywalker when you're searching for Star Wars. And you say that's because the AI that's where the magic is. The magic is the AI taking this phrase or this paragraph or this sentence or whatever and turning it into a representation of numbers that mathematically relate to other things that mean the same thing. So a mathematical representation of meaning is a magical idea. And a lot of people don't really wrap their heads around that as well. And when you do, when you actually catch that, it opens up a lot of possibilities. So what I did with this was I actually took the description of the book, which actually is AI generated. I had these 105,000 books, and I didn't have a description, I didn't have a genre, and I passed it through AI, looping it through, and generated the genre, generated the description of the book, and I then, on this case, I'm doing a semantic search for this description compared to all the other descriptions of books in this database. But on top of that, I went through and I weighted that. So there's I ran it ahead of time because it takes a little while to run, and I'm working on figuring out how to optimize that. But what I actually did was, from 1 to 10, you have, like, 1 means I hate the book, like 5 means I'm neutral, 10 means I really, really love this book, okay? And so what I did was I weighted that semantic search, like how did it rate in comparison to this, and if it's a negative, like in other words, I really hate this book, then it puts a major negative on that semantic search result. If it's a really positive, then I increase the semantic search related to it. And then I combine all those into a single semantic search so that all of my, the numeric results here, like this book, of course, The Hobbit is The Hobbit. This is the young adult version, but here are another Calvin and Hobbes book, which I think I have Calvin and Hobbes books in here. Anyways, but it comes back with a lot of Calvin and Hobbes type stuff, but anyways, it has other books like The Spine of the World by R.A. Salvatore. It's not actually searching on the author, even though this right here is written by R.A. Salvatore. But it's searching on the description of the book, and that I really like this book, and this other book is a lot like it. It just happened to be written by R.A. Salvatore. So it's actually combining all of these different ratings with all the semantic searches and figuring out what books will I like out of these 105,000 books. So it's an advanced way of using semantic search, but it's definitely semantic search. It's actually doing a semantic search on each of these books and then adjusting that semantic search or according to how much I like the books. So again, this is a use case that you can do with semantic search for all different kinds of possibilities, whether or not you're talking about how much your customers like a certain product, or recommendations of movies, like Netflix or different things like that. So that type of a functionality is, and I guarantee you that Netflix and things like that are using a semantic search type functionality in order to give you your recommendations and such. So like I said, you have recommendation systems. Another thing you can do with semantic search is being able to find reports or processes. Like if you have a lot of processes in a large system, if you give a description, block description to each of those processes, each of the different reports, then someone can simply type in what they want to do, and it will find the report that's closest to, or the process that's closest to what they're trying to do, and suggest it to them. And then those processes are still FileMaker scripts, FileMaker processes that you've built. But I've had a lot of systems that customers tend to get lost in just because there's so much functionality. And so that's one thing I'm working on with one of my customers to do is to open up their ability to find reports they need that aren't run that often by being able to search for a specific thing. On top of that, you also can, we're getting into more and more about those reports being just dynamically generated on the fly with AI and everything like that. But another thing that you can use semantic search for is comparison of clients. For example, I have a customer I work with, Taylor, working with the homeless. And one thing I'm working on with them is we have a large history of homeless people that have been matched to agencies that work well for them. And they've succeeded with these agencies. Certain homeless people will succeed well with one, and they won't succeed well with another. And we may not be able to see just off the top of our heads why. But what I'm doing is I have a list of a whole bunch of, I have all the success stories basically. And then I'm doing a semantic search of a description of that person along with all of the questions that they've answered and all that kind of stuff to who we're trying to match right now. So we have a person we have a list of 500 people who have been matched well with services. And we have all the information about them, including a bunch of questions they've answered about, their homeless status, and we have a race, age, just a long list of questions. A new person comes in, they want to be able to match to that, to find a thing. And one way we're working on doing that is by say, okay, here's this person. Who is the closest match to that person? Just a general description of the people that have had good matches. Okay, here are the places that may be good matches for them based on that. We're doing it other ways as well, but matching customers with customers or stories with stories, a lot of different ways that you can look at information that doesn't have to be the way we always have done it with all these key fields that we're lining up, this equals this and this equals this. And the problem with that is, with doing those key field matches, is that what if, what happens if 6 out of 7 match? There's no match. Whereas if 6 out of 7 match with a semantic search, we have a good match. And so that's one of the strengths of semantic search, is to be able to do that kind of key matching with 2 stories. And I'm knocking that microphone around here. But the next thing I want to look at, and I've kind of hit on this in the past as well, but doing doing the generation of vector views of your semantic search. And this is one thing that really helped me. I'm actually going to start this running. Let's see. I'll go ahead and click this first. Oh, that's not good. But, okay. So while it's running, I'm actually just doing semantic search with this funny comic strip books here, right here. And what it's doing, the thing that takes the longest on this is I'm padding my find. So it does a find pretty quickly, but then it pads that find with a bunch of random books. And there's probably a better way to do this. What I did was I just randomly jumped to different records and added it to the group. I could probably add it by chunks of 10 or 20 and speed up the process a lot faster. But basically, I have my found set of what was a good match for this phrase, and then I'm adding a whole bunch of other random data to that. The reason why I'm doing that, I'll show you in a second, is I'm creating a cloud of all this information so you can see how it maps and how what I found is actually close together. So this process is taking that mathematical jumble of numbers, which is like between 1,500, 3,000, whatever numbers that represent the meaning of that information, and it's reducing it. Oh, it reconnected. No, it didn't reconnect. It did reconnect, but it I don't know why I'm gonna. I'll have to check that. And this was working this morning, so of course, we're going to have bugs with it. But anyways, it takes all those numbers. It's just a big cloud of numbers. And mathematically, it reduces it down to 3 numbers per book. And so that allows us to map it with X, Y, and Z and get a 3D view without losing the information, which is the magic of the process. So when this finishes running, I can show you. But basically, it makes a 3D cloud that you can navigate, swirl around, move. And the unique thing about this is that so for example, the genre is not mapped into this. But what you see now, I've shown in the past, is that when you look at this cloud, you will see all of the mystery books all grouped together, and all the history books grouped together, and the science fiction are over here. And they're colored differently so you can see it. So that's cool, but what does it mean for a business? You can take your customer data and their history and different things like that, or whatever you're trying to look at, and map it like this, and you'll see, wait, okay, for example, in the book thing, here's a whole bunch of science fiction all together. Wait, there's one science fiction that's way over here by the history. Why is that different? Why is this piece of information so much different than the rest of the science fiction books? Or why is this customer so much different than the rest of the, oh my goodness. You can see it on my videos online and how I've presented in the past, but the thing about it is the key concept is that mapping this data allows you to see what is the same and what is different, and did you expect to see that? In other words, these customers are happy, these customers are not, but is that data in about what makes up that customer? Are they all blurred together and there's no similarity? Or are they separated and you can see, oh wait, these customers with this information, they tend to be happy. So let's jump to the last piece here. So this last bit here, this is actually, what I did was I took a whole bunch of, in fact, all of the videos from the FMPUG that I found online with Harmonic and Taylor's playlist and everything like that. And I got all of the transcripts from all of them, and I broke them into a whole bunch of different files here that make up that thing. And I did semantic, and I did embedding on those, so that I can use those to search and to find information, stuff like that. And one thing that I used for this, I just want to touch on this real quick, is a thing called Fabric. So Fabric is primarily a command line utility that you can install. But for example, I have here, let's see, this little YouTube ID right here, that's Heather's presentation on the HIPAA compliance. And so all I do is I have this little YouTube, get the transcript for that thing, and then I'm piping it or passing it into this Fabric. And I have a prompt here that's called extract wisdom. This last little piece here is just because it puts out some error messages that I don't want to see. So I just ignore that. But when I do this, well, it still gave me a thing. Because I'm not connected to the internet, that's why. All right, that's probably easier to see for y'all anyways. So let's see, do I have, no, I don't have to do it. Let me do a search real quick on, I'll find Heather's thing here. So this is, where are we? There it is, HIPAA presentation. There's our link right there. All right, so we go, let's see. And just a short, and then pipe that into this one's called extract wisdom. And then we'll see how much wisdom is in here. I think there's probably quite a bit. All right, YouTube, got that. Now wisdom. All right. Sooner or later, it's pretty cool when you see it. So here we go. All right, so yeah. So as you can see, it has the ideas that were presented in there. It has insights that it took away from the thing. It has quotes from that video, and this is one of the things I use because I don't have time to watch all, especially when you're talking about AI. I don't have time to watch all of the amazing amount of videos and things that come out all the time. But this kind of thing will allow me to take any video and I have facts, I have references, I have recommendations, familiarize yourself with HIPAA regulations if developing FileMaker apps for the medical industry. And so it's just, these are all the things that it gleaned off of with a prompt that it gleaned off of that video and summarized it down for me. I have another one I'm not going to get into right now, but you can do all kinds of things like rate let's rate this video based on how urgent is it for me to watch this video. In other words, this has a lot of good information based on my criteria of what I'm looking for, you need to watch this right away, or you can wait a little bit, or whatever.
So it basically creates your own cliff notes.
It does. Creates your cliff notes for that whole cliff notes there. But, so going back over here, we have, like for example, I have a quote that I have here, what's new with FileMaker 2024. And if I send that off, what it's doing a semantic search on all these videos here. And it goes off and it takes those chunks of information and it sends it off for a chat request, just like with all that information. And then here's what I got back. The information, and I added this where I have those videos what videos did it use to get its information. I passed it a bunch, but it said, these are the ones that I like to answer this question with. There we go. So it will not only jump to that video, but it will jump to that part of the video that this is referencing. And it actually has start and end, so it will actually play that much and then stop or whatever if you want to. But this allows us to not only just get an answer, but have it validated. This is why they answered this way. And here's the clips if I want to jump to that and see what's going on with it. So as you can imagine, that alone, whether it's video or it's text or whatever, if you have your customers have a corpus of information that they're wanting to use to answer their own questions, that this RAG is what you're going to use, retrieval augmented generation. And basically, you are the source of truth. So you do your semantic search in FileMaker with whatever data that you put in there, whether it's a whole bunch of help files or it's a whole bunch of information about how to do things or video information like this. And then it does a semantic search, retrieves a whole bunch of information, sends all of that along with the question off to the LLM and gets the answer back. And now you're controlling, that's how you control not getting hallucinations. For the most part. I do have it give me some really crazy answers sometimes, and I'm like, where did you get that? And it didn't even get, like it picked some random videos that had nothing to do with that subject. But, so what tools and functionality? Here's another one. So what tools and functionality can I use to enhance my FileMaker system? It says you can use the new on-window transaction script trigger. So it's interesting because I get different responses all the time with this. Okay. I have different responses all the time. Sometimes it will tell me use JavaScript, use add-ons, use all different things, and it will come back with different answers based on, what it feels like at the moment. But it's getting good information, and this is a way that you can support your user with, again, a lot of information. Most companies have a stockpile of information and text and things that will be good to use to provide that information because it's just sitting there. And it's sitting on, oh, wait, what? Our employees have access to that information. It's over there on the D drive, And, but there's really not, nobody looks at it. Nobody really has access to it. They don't have time to really get things done they need to get done, much less go and find the information they're looking for. So retrieval augmented generation is what makes up part of that is the semantic search. Semantic search allows you to dump all of that information or find the information that is relevant to their question with the semantic search, dump it into a prompt with their question, and then get the answer. And that is very, very powerful. So that's all I have for now, so we can...
Okay, now we're going to be moving on to Jeremy Bante. He's going to be sharing with us his stuff. How's everybody doing out there?
So, I'm Jeremy Bante, and I am on the market for an apartment right now.
Tell your mother.
And so I'm on the market for an apartment, and naturally I turned to FileMaker to help me find the department, because Craigslist, while that is a place with all of the data, it's just not organized quite the way I want. So I put this little app together that goes onto Craigslist and scrapes every single ad it can find in the Los Angeles area, and scrapes out all the data, comes up with an aggregate ranking for the data so it can sort them the way I want. But what it finds is 32,000 records, which is a little bit more than I actually want to look at any one moment. I don't have that kind of time. But the first issue I run into looking through this data is that most of the posts on Craigslist are duplicates. So it's kind of a waste of my time to look through the same apartment 10 times. And what's worse, it throws off my numbers. I'm very defensive about my numbers. That math degree's got to count for something. So, in comes FileMaker Semantic Search, which helps me find all the duplicates. And you can't do an exact match search because these duplicates, the people posting them are kind of smart. They don't put the exact same wording of the post every single time they repost it. Sometimes they do. Half the time they don't. So no standard FileMaker search would find the duplicates, but Semantic Search isn't looking for exact words. It's looking for the rough meaning of the data, and it works great for this. So as part of the scraping process, I put together send the data off to OpenAI for an embedding, and it's okay in this case to go ask OpenAI for an embedding of this data, because it's not private data in any sense of the word. These are publicly listed advertisements of people who are trying to get public attention. It's okay if OpenAI sees what they have to say, too. And I use the small embedding that OpenAI offers because it seems to work well enough, and it is cheap. You know, after making the embeddings for these 32,000 records, I still haven't even spent a whole $1 yet, to give you an idea of what this kind of thing costs to do. But to actually find duplicates as part of that scraping process, I have this script here that just takes in the ID of the post I'm looking for, gets the vector of the post that I want to check for duplicates, then goes and establishes a found set of the embeddings that are all based on the same model. That can be important if you're using more than one kind of embedding model, that you're checking for against embeddings against the same model. Because if you get embeddings against different models, they're going to not going to work well. And then once it finds the closest matching records, it just performs a semantic find there. And my scrolling is not working the way I want for some reason. There we go. Semantic find gathers, and it's not doing anything fancy in there, just compared against the vector from the post that I just scraped. Compare that against the embedding vectors for the post that I have already scraped. And then just gather up those results to pass to the next script in the chain, which goes and confirms each of the potential duplicates. If the location is an exact match and the rent is within about $100, then I call that a confirmed match. Because there are a lot of these potential duplicates that look kind of close, which happens a lot in this housing market data because it's a really homogeneous kind of language that they use in these housing posts. A lot of people are looking for kind of the same thing, so a lot of people posting posts tend to say kind of the same thing. So it's helpful to have this additional data to confirm whether or not the data is an exact match or not, which comes up to one of the big points that you have to keep in mind when looking at or using semantic search data. If you need the semantic search itself to be exactly right every single time, that's not going to work well for you. This is approximate, mushy, kind of works most of the time kind of thing. You do not want to be writing your legal contracts this kind of way, or you do not want to use this to do your accounting This is,
It's about right.
yeah. It's about right most of the time, but it works well enough for me. It doesn't catch all the duplicates, but it does catch the overwhelming majority of them. So it filters out about 3/4 of all of Craigslist is easily parsed out duplicate posts. That still leaves me with 9,600 posts that are not duplicates to find and filter through. And that's still more than what I want to do, want to deal with and look at. So there are a few filters in there I have that will automatically flag and reject posts if they have things I don't like about them, like if they have on-street parking, which does not work in Los Angeles at all, kind of thing, or if it's too far from the nearest grocery store. But that still leaves me about 400 posts to look at, which is way more than I can actually go and look at in person. So what I did is I put something together to recommend posts. I've already looked at some of the posts and sort of flagged which ones are worth my time to look at and which ones aren't. And what that gives me is training data that the semantic search can look at and try to recommend posts that are more similar to the posts that I flagged as worth my time to look at and less similar to the ones that I don't want to spend my time looking at. And I did that by using semantic search as the basis of a k-nearest neighbors algorithm. Now, for you, those of you who have not studied machine learning in any depth, first think about your embedding vectors. They're new-fangled contraptions and fancy and can seem complicated, but really what you're getting back from your embedding vector, it's just a point in space. It's a high-dimensional space from 1,500 to 3,000 dimensions, but still just a point in space. And in that point in space, you can have a query. Like I have a new post that I want to decide whether I'm going to recommend that I look at it or not. And the semantic search, one of the options it has is to just look at the top n or k vectors that are the closest matches to it. And now if I take those closest matches and just count up how many are positive recommendations and how many are negative recommendations, and just let the majority rule, that's your basic k-nearest neighbors algorithm. And FileMaker Semantic Search already gives me the first half of that, finding the closest values. All I have to do after that in FileMaker is loop through them, count up the votes, and figure out which ones are in the majority, which is exactly what I wound up doing. I have this script here that, it just takes k and the embedding model I want to work with as parameters, goes and looks up the vector for the post that I'm deciding whether or not to recommend, then finds all of the vectors that I actually have ratings on, does my semantic find on those, and then I just tally up an average of the votes from those vectors, those closest vectors that the semantic search found, and whatever's in the majority, that's my recommendation. And that worked okay. Now, when doing these kinds of things, how we measure the accuracy of the model becomes very important. The conventional way to do this is a process called cross-validation, where we take some of our data and let the k-nearest neighbors algorithm use that to decide what the majority vote should be, and then hold out some other set of the data to look at and test on, to look at what the actual accuracy of the ratings are, so that we're not contaminating our predictions of what might be based on what we already happen to know. And this is usually done by splitting the data into several blocks so that every single data point has the opportunity to be used in that training data and that testing data. By splitting it up into separate blocks or folds, they typically get called. And then we'll have one test set where we've got one fold held out for test data and use all the rest for training data. Then we do another set where we've got the next set of testing data, and all the remaining data gets used for the training data, and so on, until eventually all of the data has the opportunity to get used as the test data, so that we get a fairly robust estimate of what the accuracy is going to be when we use our classifier on data that we haven't seen yet. What we found with the classification performance is that with base k-nearest neighbors, the overall accuracy was about 68%. That's a number we're mostly going to ignore because accuracy is not a very good measure of performance for imbalanced data sets. Now we have here the total number of actuals is 119, and the total number of actual positives that I want to look at is 119, and the actual rejects is 285. That's a very imbalanced data set, which leads to a lot of problems with measurement, because it can look like accuracy by itself can make it look like we're classifying things very well when in fact we're actually not, because it's just always going with whatever the majority class is and failing to accurately classify things in the minority class. And so to deal with that, there's this other measure called G-mean, which is the geometric mean of the true positive rate and the true negative rate. And that does a better job of balancing the majority and minority class accuracies. And yes, the G-mean happens to run on 0 to 1, and for that classifier, it happened to be 0.575 was the score we got for that. But with imbalanced classes, this is something not only do we have to be concerned about it when we're choosing what performance measure we're using to decide what classifier we're going to use. K-nearest neighbors is very easily thrown off by imbalanced class data. Because when you take one class and reduce the density of it, it can look like a query point belongs to the wrong class just because the density of the class it belongs to is a little too low in the neighborhood of where you're looking at. So in the example on screen, we've got data that would have been classified as a blue square ordinarily, but because the blue squares aren't dense enough, it actually gets classified as a red circle instead. To deal with that, the first technique I tried is undersampling, which is a technique where you look at the class the majority class that's overrepresented relative to the minority class and just randomly remove enough of them so they're more balanced again. And in FileMaker, what that looks like is first have a script here that undersamples the posts. It goes ahead and uses execute SQL to just count how big each of the classes are, decide which one is too big, then finds the records for each class and samples them. If the class that's too big, it's going to start with the whole found set of all of them and just randomly knock out things from the sample until the samples are the same size. Once that's done, the k-nearest neighbors, when it's doing the step of looking for the in-sample neighbors, it's just going to look for a different set of records, a different smaller set of records, as its training data. And then otherwise, it runs exactly the same. And the performance of that is a little bit better, 0.592 instead. The accuracy number that we aren't actually using fell down, of course, but the accuracy of its performances on the positive class on the records we actually want to see actually did a whole lot better. But that's only one way to do it. The other big thing about dealing with semantic search and AI, and especially if you're trying to do any sort of machine learning like this on top of it, is that you have to do a ton of experimentation. This is not like regular FileMaker programming where once it works, and you can just run with what you have. there are lots of opportunities for it to work better. It's more like performance tuning, where you have to have lots of ideas and actually try all of them out and see how they all perform. So the next thing I tried was similarity weighted KNN, K nearest neighbors. Or instead of undersampling, which I'm personally not partial to because it means I'm not getting to use the whole data set that I had, and I might be losing out on some insights from all of that data. This instead takes the nearest neighbors and weights them based on how similar they are to the query point that we're asking, that we're trying to decide whether or not to recommend. The ones that are closer to the query point get bigger weights. The ones that are further away get less weight. And in FileMaker, again, this is pretty simple. It's mostly identical to the other k-nearest neighbors algorithm, with the exception that each post gets a weight here. And that weight that goes into the average vote is just the cosine similarity. Now that's going to give us a number between -1 and 1. Of course, negative weights don't actually make sense. So in this case, I had to limit the semantic search so that it only caught values where the similarity was greater than 0 first. But other than that, there were no other differences with standard k-nearest neighbors to change. And this actually got exactly the same performance as standard k-nearest neighbors. This made 0 difference. Your mileage will vary with this. A different data set will get a different answer. Now, a similar concept to this is to use distance as the weight instead of the similarity. This is very similar to the last example, except instead of using the similarity directly as the weight we use on the average, first we convert that similarity into a distance. Because the similarity is a cosine similarity, the arc cosine of that literally gives us the angle between the two vectors, and that is a valid distance between the two. And the weight is just 1 over that. And then it does the same sort of weighted average of the examples. And this one, I believe, does a little bit better. The G-mean of 607, and the accuracy actually goes up this time. The next thing I thought to try was class-weighted k-nearest neighbors, where instead of weighting the different examples in the vote based on how similar they are, we weight them based on what class they're in. The heavier class, or the class with too many examples in it, gets down-weighted, and the class that doesn't have enough examples gets up-weighted. And then hopefully that cancels out the effect of the class imbalance. And in that case, in FileMaker, we have the additional step at the beginning where we have to sort of use execute SQL to count up how many of each class there are. And then the actual weights that get used for each class is the reciprocal of its frequency within the data set. And the final performance on that is, again, a little bit better, 0.648. Accuracy went down a little bit, but the G-mean is what we care more about. In this case, we can see that the accuracy on the recommendations that we care about more did go up significantly. The next thing I thought to try was bigger embeddings. I've been using the smaller embeddings because they're cheap and they run fast. But the bigger embeddings have more dimensions to them. In this case, the OpenAI's larger embedding has twice as many dimensions in it. And maybe there's something in those higher dimensions that is more discriminative between the posts that I want to recommend and the ones that I don't. And that is, in FileMaker, that's just a simple matter of going and getting additional embeddings for the records that I already have. The performance of that actually went down a little bit. And what happens is that when you have this many dimensions, you run into something called the curse of dimensionality. As you add more dimensions, your embedding vectors on average tend to get spread out a little bit more from each other and more uniformly spread out, so they're harder to differentiate one class from another. And as you can see, I went and looked up sort of what's the average distance between any two vectors with the two different embeddings. And with the small embedding, the average similarity was 6.22. With the larger embedding, it's only 6.03. Not as dramatic an effect as I was hoping to demonstrate with the cursive dimensionality, which is a credit to how good the OpenAI embeddings are. But this was a step in the wrong direction. So I thought, why not take a step in the opposite of the wrong direction, and let's make smaller embeddings. So what you can do with the embeddings is you can start with a smaller embedding, and because these are what OpenAI calls matryoshka embeddings, thinking of matryoshka dolls as the metaphor, the first several dimensions of an embedding are sort of the juiciest, most discriminative dimensions in the embedding that there are. So what you can do is just chop off the last several hundred dimensions. And the embedding that you're left with, after you renormalize that vector, is still pretty good. When you reduce the embedding by half, the average similarity goes up instead of down. It goes up to 0.638. And that, again, improves the G-mean up to 0.65 a little bit. Trying that again, having the dimensions down to 384 made the G-mean reduce again instead of increase. I guess somewhere between in the 768 dimensions range are the dimensions that we want to help discriminate between recommended posts and not recommended posts. But after doing all of that, I got that 768 dimension embedding with a class-weighted k-nearest neighbors classifier, gave me reasonably good accuracy so that I could reduce my 9,000 different posts to filter through down to just the 7 that got recommended for me to look at next, which is a much more reasonable use of my time. And now to make a more reasonable use of your time, it's time for the next presenter.
Okay, coming up next, Eric, Randy, they have been working on this diligently. I'm excited to find out what it is they are doing.
I'm going to start my presentation with a meme. And this, Paul shared this about a month ago in one of our Slack channels, and I just thought it was great, because this is kind of my general feeling about a lot of the AI. It's like, cool, it can do all these things, and you look at actual user needs. It's just like, right, but like, why do I care? Like that doesn't serve something that that I care about, or may serve your organization, what you're showing as an example, but it doesn't serve mine. So I thought about what business problem do we at Harmonic have that is worth solving, that AI can help solve, and a very present one is, how do we estimate accurately? We care about estimates because we want to be able to tell a customer, here's how much it's going to take to build this thing for you. Our customers care about estimates because they want to know how much it's going to take. And we also don't want to spend hours and hours and hours and hours estimating and then give the customer a number and then them decide, it's actually more than we're willing to spend, we're going to go a different direction. Well, it would have been great if we could have found that out in a few minutes rather than spending hours doing that. There's also the emotional side of estimating, is you're sitting there looking at a list of tasks, and you can go one of two directions. You can go, well, if I estimate too high, then the other person is going to think I'm dumb and incompetent. Because, gosh, why would it take you that long to do it? And so you want to be optimistic. So you end up underestimating. Or you go, I don't even know. I'm so afraid of underestimating that I'm going to overestimate by so much that it's, you're overestimating by 6, 7, 8x, which is, again, not useful at all. So I'm going to kind of show the power use case that I've got here, and then kind of walk back through how we got to this point, and kind of where we're going to go next. So what I have here is just a text file of tasks, just essentially a to-do list for a project. I'm going to drop it into this container field and select some options, which I will explain as we go along. Click the button. And I should explain the reason we have Randy's computer here connected to my computer is we are not using OpenAI for any of this. We are using our own embedding server. And for the time being, this machine is our embedding server because we had an extra MacBook Pro lying around with an M1 Pro processor. So we said, hey, we already own it. Why send our money to somebody else? So it's imported this task list, and it's going to put estimates into all of these tasks, and then we get a grand total. And that was taking, I don't know, roughly 30 seconds or so to rip through this whole long list to do that. Now, the way that we're doing that, so we started with asking the question, what data do we have? Well, we've got 7 or 8 years of project management data. So, in our project management system, we've got lots of tasks that have titles and descriptions and a bunch of comments. And then we have, in our timekeeping and how we invoice, we have time that's booked against those individual tasks. So all of this estimating is based on our own internal data. So we took, originally, we took the combination of the title, description, and comments and created an embedding of just that, which is this ticket details option that I've added here. I said we put together a private embedding server, set up a sentence transformer that is capable of embedding that input into a vector, and then we just drop that vector into a container field. So what this is going to do is I'm going to take that task and choose which of the 3 embeddings I want to use, and I'll get into what those other 2 are now. And I'm just going to say, hey, estimate that. And this is saying, hey, based on 100 similar tasks, I've set the limit to 100, we think this is going to take 28 hours. And what we did that semantic find that you've seen previously, and then just did some super basic statistics on it. We just did an average, and then I showed like a min and a max and a standard deviation, right? And then, but where can we go from that? Now, before I jump into how we started refining this data, I do want to touch on how we set up our private embedding server, because we're not using OpenAI. Part of that's because, well, we didn't want to pay for it, but also this is our data, and we don't want to be sending that out to the internet. So all of this has happened completely within network. It's never left our network, never left our office, which is great. First, we set up an embedding server using Ollama, which is just an open source AI embedding tool, and it didn't work. And the reason is twofold. The way FileMaker 24 has been coded by Claris is it works with OpenAI, and OpenAI's routes, the route pattern, and responses, and so it's expecting that specific format. So we can see the difference in the Ollama route, which is /API/embed, and the OpenAI route, which is /v1/embeddings. So because of that difference in route, as FileMaker was trying to make that API call through the script step that they give us, that was failing. The other thing is in the response. So Ollama's response is structured something like this. OpenAI's response is structured like this. And FileMaker is expecting the response to be structured like OpenAI's response. So Randy just built some middleware to convert the route that FileMaker is going to call, which is the pattern from OpenAI, and transform that into the route that Ollama is expecting. And then that same middleware transforms the response that Ollama spits out into the structure of that OpenAI gives. And then it worked just fine. But what I just demoed was actually not using Ollama. What we did, Wim de Kort has a great article on how to go about setting up a custom embedding server. And as it turns out, FileMaker Server 24 ships with a Python file on server, and it's documented where on the server that gets installed. And so you can, the story goes, you can take this file as is, put it on a different server or on your FileMaker server if you want, and then you're just able to call it. And for the most part, everything that Wim said in that article worked for us, with one exception. And for those of you who are techie that care, I wanted to call out the one thing that we had to change. Maybe we were missing something, and this is why we had to change it, but right here. So in the Python, I say we changed it. Randy changed it. He figured out what was happening and got this resolved. So this line here, 287, that we're commenting out, was what was in the Python script that Claris gave us. We had to change that one line of code to this. And the difference in those two outputs was this. So this first line, if we look at the embedding object, the script was outputting np.float32, parenthesis, number, et cetera, et cetera. Once we changed that, our output was just a number. So anyway, for what it's worth, if you're trying to set up your own embedding server, we had to fiddle with some things to get it to work, but we got it to work, and it was smooth sailing from there. So the next thing, so if you're going to build a better mousetrap, as my example is here, I don't know if 28 hours is actually the correct answer. So we started thinking of how do we make these answers that it's giving us more accurate. So Randy got the idea of, well, let's take the task title, description, and comments, and feed that to an AI, essentially chatbot, and ask it to summarize it for us. And then take that summary and embed that. So if I choose the second option, which is the embedding of the title, description, and comments, and the AI summary, so all four of those things, and I run that again, I still get 28 hours. Okay, I didn't change it all that much. If instead I switch to just comparing against the AI summary, it goes down to 23 hours. Well, that's interesting. Which one of those is more accurate? I haven't determined yet. But so there's those different knobs that we can turn. Another knob that Jeremy was mentioning is the cosine similarity. So if I constrain my results to similarities that are greater than or equal to 0.45. I chose 0.45 because in my testing I found with our data that generally produced something that was okay. Hey, now that jumped down to 9 hours. which depending on how better of a mousetrap you're going to build, that may be significantly more accurate. But you'll also notice that we're only comparing against 25 tasks now because it constrained what we found. Now, the next idea that we had was if we look at our min and our max here, so the minimum number of hours of these related issues was 1 hour. The maximum was 64 hours, which seems like a lot. Yeah. So I said, me as a human, knowing what I mean by build a better mousetrap, saying, no, it should not take more than 25 hours. Now, even 25 hours, that's a significant investment in a mousetrap. But, so this is just going to omit anything that is greater than 25 hours before it runs my averages. Now it drops down to 5 hours. It's omitting those things that are too big. You could also do it in the reverse, where, hey, what I mean by build a better mousetrap is we need to spend at least 30 hours on this. Anything less than 30 hours is just not worth thinking about. So if I rerun that, well, now I've changed it to 60 hours because I'm omitting those things that I, as a human, know don't accept anything that's lower than this number. The next thing that I played with, kind of along that same line of the estimation, was I wanted to exclude outliers, right? So if I've got a found set, so let me look here. The data that it's actually looking at right here is these records. And if I look at this spent time column, well, there's not really a good, okay, here's, I'll do this one. Add a print button. I want to go back to that one. Okay. So the max it's saying is 501 hours for adding a print button, which, I don't know, seems excessive. Just a little bit.
But does it really?
So I can see in here that it has found, I mean, there's something in here, 207 hours that it's found something that it thinks is somehow similar. Okay. 501 hours for something that it thinks is similar. Clearly, it's not similar. Or that's a very nice print button.
Lifetime upgrade.
Yeah, right. Printer support included. That's probably why it's so high, right?
It's on Windows.
Yeah. So I added this option to exclude outliers. And the scripting for that is really quite simple. An outlier is defined as something that is greater than or equal to 3 standard deviations above or below the mean. So once I get my found set here, I am going in and finding what is our standard deviation, and then just doing a find to omit things that are greater than 3x that away from the mean. And when I do that, that 20-something hours jumped down to 15. And now my max is 162 hours, which still seems like a lot for adding a print button, but significantly less. And so I don't have to know what should my range be. I can just say, hey, exclude the outliers, period. Before I get into weighted average, because I kind of nerded out a little bit on that one, part of this in getting good responses is to know your data. So the semantic search is just going to find similar things to whatever you pass into it. But it's up to you to decide, is this data point even worth considering in our data set? So I added a number of things in here. So for instance, starting here, I said hey, I only want to include things that are done, right? If we are still working on a task, well then the amount of time that has been booked against it is useless for this case. It's going to skew the numbers. So I'm going to constrain to things that are marked as done or closed, and only find things that actually have time spent on them. If there was no time spent, well, that's also going to drastically throw off the numbers. I'm also here omitting records that have a resolution. So one of the columns in our project management is called resolution. And we have 2 data points that we've set up. One is called won't fix, and the other is duplicate. So if we or the customer has made the decision that, yeah, we put maybe some time on this, but we're just not going to do that for whatever reason, well, then I don't want to include that in my results. Also, if we've marked an issue as a duplicate of something else, I also don't want to include those numbers because they don't really count. And I as a human know that they don't count. I as a human who knows my data knows that they don't count, that I don't care about them for this purpose. Then there's some other things. I'm omitting these, so we have a series of tasks for when we do go lives for customers, and the title of the task is, build 170, build 171, build 172. Well, they have the word build in them. And so the semantic search goes, build, that's similar. And it includes those. And I just go, no, that is, we're not using build as a verb there. This is a noun. So I just said, yeah, just for those, because there are so many issues or so many tasks that have that title in our data, I just said, no, just omit those. And some other things like that. So knowing your data. The last thing that I did was I wanted to weight the average. So if I look at my data set for adding a print button here, and I'm going to sort by our similarity. So I see there are some things that have a similarity of 0.46, so on and so forth, and other things that have a similarity of 0.63, right? Well, the things that are more similar, I would like to have those averages weighted a lot more than things that are dissimilar. And so there's a standard equation to calculate a weighted average, just using the AI similarity as your weight. But that didn't get me the results I wanted to see because it wasn't weighting them enough, right? So the cosine similarity value that's returned is just linear, and by that I mean the distance between 0.45 and 0.46 is the same as the distance between 0.6 and 0.61. And for my weighting, I didn't want that relationship to be linear. I wanted that relationship to be exponential. So the more similar it is, the more it weights. And the less similar it is, the less it weights. So what I did is I created a field, where is it? There's that. There is. Okay, here it is. So I created a calc that takes that similarity and just transforms it into an exponential relation rather than a linear one. So this effectively is e to the power of 100 times that similarity. I'm going to change that to 1,000 because I think I liked that one better. But that started out as 5 times the similarity, and I went to 10 and played with numbers until I found something that felt right to me. And like Jeremy said, you've got to play with the different knobs to see what actually ends up getting you the best results. So if I use a weighted average, now all of a sudden that jumped down to 6 hours. Well, that's, and then if I say increase the cosine similarity, it stays 6 hours. Okay, it's probably because of the weighting I was doing. But that use of the weighting really reduces the amount of time, and in our case here, hopefully makes it more accurate. I can see that the maximum here is still 64 hours, which seems ridiculous. I'm going to just omit anything that is greater than 30 hours. Okay, I still get 6 hours as the estimate. What if I say omit anything greater than 20 hours? Okay, that weighting is strong.
Treat it like you're actually doing it. How long do you think it would take to build a button?
Yeah, well, so that's the interesting thing here is I actually think, 6 hours might kind of be reasonable, because there's if by building that print button, you need to build a new layout that is printer friendly, and then fight with all the little gotchas and stuff there, and then pass it off to the customer to test, and then they go, well, I would like these two fields, and could you reorder these, and I would like this sort, and then that back and forth. By the end of that, you may actually be 6, 7, 8 hours in. Like, that is entirely possible. The initial work may only be 2 hours or 1 hour, but then there's all the ping pong that happens back and forth. So I'm going to try this one more time, where the goal is, okay, let's try it with something smaller. So that's just a different file. Use the weighted average, sure, all of that sounds wonderful. So what this is doing, there we go, boom. So it's saying for this task list that I just uploaded, it compared it against our historical data of what it took us, and it's saying, hey, for this whole set of things, on average, we think this is going to take 80 hours. I don't know if that's true. We're still fiddling with that. But a few caveats to this is it's all influenced by the quality of your data, right? If you're in your project management data, you have one task that you've put 800 hours against because it's just the whole project. That one data point is going to throw everything else off. Because when you put that much time into one thing, that estimate is basically worthless. Also, if you have lots of little tasks, you say you've got something tasked out with 10 different tasks, and then you do all of that work against 2 of them, and you put no time against the others, that's also going to throw off your data. So one of the things that we're going to try to get better at is better project management hygiene, right? So naming tasks better, being more diligent about adding comments to issues. Because if the only comment on the issue is, this is done, well, that's not all that helpful. This is done, and you've plowed 70 hours into it. It's like, well, okay. If it's fix the button and then this is done, that's not a lot of context for the AI to go off of. I think the one last thing I'll throw in is kind of where we're going next. That was actually Randy's idea. We just didn't have time to implement it. Was implementing the chat with database feature into this. So, like I'm manually doing in the scripting by omitting certain things from my find before I do that semantic search, wouldn't it be nice to, oh, that's not what I wanted to do. Wouldn't it be nice if we could enter in the name of a task and then based off of that, chat with the database that would give us a SQL query to essentially find things that meet this classification, and then strip the where clause out of that SQL query and add that to our find request to further limit down the results dynamically before we even do that semantic find. So that's, I'm hopeful about the potential value that that could bring, and I'm hopeful about what this tool can do for us internally at Harmonic and the value that it can bring, and the turnaround time to produce estimates for things, and then that allows us or the customer to decide, is it worth moving forward with this? The faster we can come to a decision, the better for everybody involved. Yeah.
I don't know if you thought of is, like, you have all this data that has all these descriptions of things. Having the AI ask you, the LLM ask you questions, like you put in this task, and it can ask you, is this more like this, or is it more like this? And to narrow down that search as well.
Yeah, I think Randy, you had some ideas around that. But that's, but for instance, if what we're doing is adding a print button in FileMaker versus adding a print button on a web page, well, that's two different sets of work. And typically, it's going to be a lot faster to do it in FileMaker than it is in something else. So, which team at Harmonic is doing it, what tech stack is this work being done in, that can greatly affect the amount of time.
And we do want to invite everybody to come out to to the Tollway Towers South Tower and join us live, because if you were to come here, you too could be now being forced to go and enjoy Taco Bar. Taylor?
Next month, we will be meeting, I think it's September 6th. We're going to be talking about SSL certificates and Let's Encrypt. So if you're doing server management, come with lots of questions, and we'll show you what all we've been learning with the new tech available to us in FileMaker 2024. We'll see you up at the lunch bar. Take care and see you next month.